Welcome friends, this is Dr. Prashant Patil, Jain College of Engineering, Belagavi. Please subscribe my channel, give the comments and also don't forget to hit the like button. In this video, we are discussing on inverse Laplace transforms. Some different type of examples on convolution theorem I am going to discuss. Different type means if the same term is repeated, then how to find their inverse Laplace transforms easily. Okay, by using the convolution. Right here, inverse Laplace transform of 1 divided by s square plus a square square is there. Okay, this one I can write it as inverse Laplace transform of 1 divided by s square plus a square into 1 divided by s square plus a square. Two terms I can split, so that it will become my inverse Laplace transform of capital F of s into capital G of s. Therefore, both f of s and g of s are my same here. Now, using the capital F of s to apply convolution theorem, I want its f of t, that is my f of s is equal to 1 divided by s square plus a square. Then f of t will become inverse Laplace transform of capital F of s, that is nothing but inverse Laplace transform of 1 divided by s square plus a square. Okay, by inverse Laplace transform f of this is nothing but 1 by a into sin at, correct? This is my f of t, and same this is also equal to g of t. Okay, because both f of s and g of s are same here. Okay, f of t and g of t are ready with me. Now to find out inverse Laplace transform by using convolution, let me apply that. Inverse Laplace transform of 1 divided by s square plus a square the whole square is nothing but inverse Laplace transform of f of s into g of s. We have written that, and convolution of this is nothing but f of t convolution g of t. And how this convolution is defined here for two functions? It is defined as integration from 0 to t f of t minus u into g of u du. Okay, or you can interchange, because commutative property holds good for this one. You can write f of u into g of t minus u also you can write. Now let me substitute these values for f of t. Integration from 0 to t f of t minus u. F of t is 1 by a sin at. Therefore, my f of t minus u will become 1 by a into sin a into t minus u into g of u. My g of t is 1 by a sin at. Therefore, g of u is 1 by a sin au into du. Okay, this one I have to integrate. Here 1 by a I can take common, but a sine of at minus au into sin au. Therefore, I can use the split product of trigonometric terms is there. I cannot integrate. Therefore, addition I have to subtract. That is 1 by a square into integration from 0 to t sin a into sin b. Formula I will write here by the side. Sin a into sin b formula I am going to use. That sin a into sin b is nothing but 1 by 2 times cos of a minus b minus cos of a plus b. That I am going to use. 1 by a square I have taken common. Therefore, it is 1 by 2 times cos of a minus b. A is this one. Okay, my a is at minus au minus au. Okay, this is my b. Then minus cos of a plus b. A is at minus au plus ab, that is a plus au into bracket du. Okay, then 1 by 2 I can take common, then it is integrable easily. 1 by 2 into integration from 0 to t, 1 by 2 a square cos of at minus 2 times au minus cos of at, and au plus au minus u cancels, only at will remain. And one thing you can remember here, we are integrating with respect to u, not with respect to t. That is again important here. Okay, now we have to integrate this. Now integrating them, I will write 1 by 2 a square outside. Integration of cos at minus au with respect to u will become sin at minus 2au divided by minus 2a. Its integration minus cos at, integration with respect to u, not with respect to t here. Therefore, this will be acting as your constant. Therefore, cos at into u is its integration between the limits 0 to t. Now substitute upper limit minus lower limit and simplify this one. Okay, let me substitute upper limit first. 1 by 2a square into upper limit u equal to t, sine of at minus 2at whole divided by minus 2a minus t into cos at. This is my upper limit minus lower limit t equal to 0, sorry, u equal to 0 now. That is sin at minus 0 whole divided by minus 2a minus u equal to 0. So it will become 0. Simplify them, we will get the required answer for the inverse. That is 1 divided by 2a square into, this will become minus of sin at minus 2at, that is a minus. Already this minus is there, one minus is there, and this one will become minus 80, minus sin minus theta is minus theta. Therefore it is minus sin at divided by 2a. This minus I have taken here, minus t into cos at. Okay, t into cos at, and minus of minus plus, minus of minus plus, that is sin at divided by 2a, minus of minus plus, and here also it is minus of minus plus sin 80 by 2a, sin 80 by 2a, that becomes 1 by 2a square into this 2, again it is nothing but minus 1 by 2, 1 by 2 will become 1. Okay, 1 minute here. This one I can write it as 2 times sin at divided by 2a minus t into cos at. Okay, here 2 cancels, and a you can take LCM, and final answer I am going to write, that is inverse Laplace transform of 1 divided by s square plus a square the square. I can write it as LCM as a, and a taken outside, 1 divided by 2a cube into sin at minus a is multiplied here, at into cos at is the required my final answer. Like this, another example I am going to solve here. If it is numerator is containing s in spite of 1, it is containing s, then how to solve this one. Okay, one more example here. Next one is employ inverse Laplace transform to evaluate inverse Laplace transform of s divided by s square plus a square, the whole square is there. Then I can write this one into two terms as inverse Laplace transform of 1 divided by s square plus a square, one term, into s divided by s square plus a square as two terms. Then this will become my inverse Laplace transform of f of s into g of s. Okay, now my f of s is 1 divided by s square plus a square, and g of s is s divided by s square plus a square. From these two I have to find out f of t and g of t. Therefore my f of t is nothing but inverse Laplace transform of capital F of s, that is inverse Laplace transform of 1 divided by s square plus a square. Therefore my f of t is nothing but 1 by a sin at. Okay, like that, this one s divided by s square plus a square, g of t is inverse Laplace transform of capital G of s, and this is inverse Laplace transform of s divided by s square plus a square. Well, therefore my g of t is cos at. Whenever it is 1 divided by, it will become sin, s divided by it is a cos. Therefore using these two I have to find use and convolution, I have to evaluate the inverse Laplace transform. Now what is my convolution then? Therefore inverse Laplace transform of s divided by s square plus a square the square will become inverse Laplace transform of f of s into g of s. We can split it into two terms, and this one I can write it as what I can say, convolution f of t convolution g of t asterisk. Okay, it is one of the operator. Now what is that operator defines? That is integration from 0 to t f of t minus u into g of u du. These two substitutions I have to do. Here integration from 0 to t f of t minus u, my f of t is 1 by a sin at, therefore it becomes a 1 by a sin of a into t minus u into g of u is cos au into du. Okay, now product of trigonometric terms is there. How to integrate them? To integrate them by converting them into product of two terms, that is 1 by a integration from 0 to a sin at minus au into cos au into du. Okay, this one, to integrate this I should convert a product of trigonometric terms to addition, that is sin a into cos b formula. Sin a into cos b is given by 1 by 2 times sin of a plus b plus sin of a minus b I can use. Okay, that is nothing but 1 by a into integration from 0 to a 1 by 2 times sin of a plus b. Sin a is at minus au plus au, then plus sin of a minus b, at minus au minus au. Okay, this is what we applied a formula into du. This one I have to integrate. Before that integration, let me simplify, then integrate. 1 by a, 2 also I'll take outside, 0 to a sin of au cancels here, at will remain, plus sin of at minus 2 times au, okay, into du. Now integrate them one by one. That is 1 by 2a integration of sin at with respect to u, not with respect to t. Therefore its integration will become sin at into u, because the sin at is acting as your constant now, because you are integrating with respect to u, plus its integration. So okay, this one integration will become minus cos at minus 2au whole divided by minus 2a. I am integrating with respect to u. Okay, this is between the limits 0 to t. Now substitute upper limit minus lower limit and simplify. 1 divided by 2a into upper limit minus lower limit for the terms, that is sin u equal to, I am replacing, therefore it is t into sin 80 minus of minus plus cos of 80 minus 280 whole divided by 2a. This is my upper limit minus lower limit at u equal to 0, that is 0 into something 0 minus of minus is plus, and it is cos 80 0 divided by 2a. Okay, this one I have to evaluate now. Okay, now 1 divided by 2a, 1 divided by 2a into t sin 80, and here cos of 80 minus 280 will become plus cos of minus 80 divided by 2a minus cos of 80 divided by 2a. But cos of minus theta is also cos theta only. One is plus cos 80 minus cos 80. Therefore, these two cancels, and my required final answer, that is inverse Laplace transform of s divided by s square plus a square the square will become t sin 80 divided by 2a is the required final answer. Okay, like this, some more examples I am going to solve in my next video. Please subscribe my channel, give the comments, and also don't forget to hit the like button and press bell icon so that you will get the notifications whenever I am uploading the videos. Thank you, friends.